Complex radicals. Today we're going to be simplifying complex radicals. Back in geometry and maybe in Algebra 1, you should have simplified radicals that were not perfect squares. So today we're going to be simplifying complex radicals. Basically, it's a number under the square root sign and it's not a perfect square. So you're not going to pick up a calculator to answer the question. You're going to simplify it using some algebraic steps. So in the past, you were told that you can't take the square root of a number. If you put it in a calculator, it's not going to give you a result either. So this is the way, or a slight loophole around that. So when you're taking the square root of a negative number, you're simplifying a complex radical. If r is a positive real number, then the square root of negative r is equivalent to the square root of r I. So there's some space in between r and I. I is not located under the radical. So let's apply that rule to the first question. To simplify this root or radical, again, you basically turn the number into a positive and then put an I. So square root of 3, I. Don't put the I underneath the symbol. Okay, so for number 2, same thing. It's equivalent to the square root of 18, I. Now, we're going to simplify the square root of 18. I didn't simplify the square root of 3 because there's nothing I can do with that information. But I can simplify 18. So what I recommend is building your factor tree. So what two numbers give you 18? We know that 6 and 3 do. We also know that 2 and 19. It doesn't matter. Just start out with 2. And then break it apart until you've factored it into all prime numbers. So 6 can go lower into 3 and 2. I recommend honestly to do that on the side, and I know I did it underneath the root, but it's best to do it on the side. So then I'm now going to list all the prime numbers underneath the sign. So that's 3 times 2 times 3. 3 times 2 from these two branches, and then times 3 from that branch. And if I multiply, all right, I double check to make sure that the prime numbers do result in the number that's under the radical. So 3 times 2 is 6. 6 times 3 is 18. Okay, and don't forget our I. That's tagging along at the end. Now the process is, if you see a pair of numbers, highlight or circle the pair. So I see a pair of 3s. What happens in that pair, and you're only allowed to circle pairs, one is always going to cancel and one always exits the root. So a 3 came outside the root, a 3 canceled, and the only thing left inside the root is 2. So 3 square root of 2, and then I is the result of simplifying that complex radical. Let's do number 3. So we have a 5 outside already. It's going to stay outside for now, but we now know that negative 72 under there is going to turn into 5 square root of 72, and then I. Now we need to simplify 72 under the radical sign. So again, let's do it on the side. So 72 is an even number, so I know 2 goes into it, and I believe it is 36 times. 36 can be broken down into 6 and 6. If you already know that you have a perfect square like 36 is, then break it down into the two numbers that multiply to give you that are identical. And if you have the two identical numbers, you don't have to build more branches. You don't have to do a 2 and a 3. That's not necessary. If you already identify a perfect square when you break it down, you don't have to break it down further. Leave it alone. But if you don't understand or don't remember your perfect squares, then break it all the way down. All right, so back to the problem. So underneath the root now I'm going to put 2 times 6 times 6. And again, don't forget I is still outside. Now, again, highlight your pairs or circle your pairs. Circle is usually best. So I have a pair of 6s. Again, in each pair, one cancels and one comes outside. So there was a 5 outside already. That 5 is outside still. But now we're going to have a 6 that joins it with multiplication. Underneath the sign, we still have a 2, and then we have I at the end. I is always at the end and never underneath the root. Well, not in these situations. All right, last thing I need to do is multiply the 5 and the 6, so that would give me 30. Square root of 2, I, as a final answer. On number 4, I have two individual radicals. So the first thing I would do is merge them into one with multiplication. So it's negative 10 times 30. And then when you multiply, you would get negative 300. So now, to take the square root of negative 300, I'm going to take the square root of 300 and put an I on it, just like we've been practicing. So now I have to simplify 300. So we already know that 300, the factors are 10 and 30. 30 can be broken into 15 and 2. 15 can be broken into 3 and 5. Then 10 is 5 and 2. So this is me demonstrating breaking both numbers into all prime number branches. But there was another way I could have did this, just FYI. So if you see the other way where you can have a perfect square factor, great, use it. All right, so under the radical, I'm going to put 5 times 2 because that's 10, my 10 branch. Then 3 times 5 is my 15 branch. And then times 2 to get the rest of my 30 branch. So I have 5, 2, 3, 5, 2. So again, I see a pair. I have a pair of 5s and I have a pair of 2s. They don't have to be side by side. But remember, one always cancels from each pair and one comes outside. So what came outside? A 5 and a 2. Again, remember they're going to multiply outside. Inside the house stayed a 3, and we have our I outside. So the final answer for this case would be 10 square root of 3 I. Number 6, we have a square root at the bottom. You're not allowed to leave square roots at the bottom of a fraction. So what you're supposed to do is take that square root and multiply the top and the bottom by that square root. When I do that, I would have 12 square root of negative 48 at the top over the square root of negative 48 times negative 48 at the bottom. Here's a shortcut tip. Here's a tip. When you have identical roots, for example, the square root of x times the square root of x, it's going to be equal to just x. Same thing if I had square root of 2 times the square root of 2, it's going to equal 2. So if that's the rule and that's the trick, at the bottom of my denominator of my fraction, I have the square root of negative 48 times the square root of negative 48. That's going to give me a negative 48 according to the rule. At the top, I still have a 12 times the square root of negative 48. All right. First thing I would do in this situation, the next thing, I would reduce the 12 and the 48. 12 goes into itself one time and into negative 48 four times. So it ends up being 1 square root of negative 48 over 4. Now I need to simplify the square root of negative 48. You don't have to put a 1 in front. I was just demonstrating that that exists. If you don't write something, it's understood to be a 1. So technically it's the square root of negative 48 over 4. Now we've been practicing these already. So the square root of negative 48 is the same thing as the square root of 48i, and it's still over 4. So off to the side, we're going to find the factors of 48. Again, look for perfect squares that you can think of. I know that 4 is a perfect square that goes into 48. 4 goes into 48 12 times. I know that 12 can be broken down. 12, it doesn't have a perfect square in it, but I know it's 4 times 3. And look, I have duplicate numbers already, and then 3 is prime. So I don't need to break the 4's down any further. I could if I wanted to. So let's go back to our root. Let's go back to our root, and underneath we're going to put 4 times 4 times 3, and then we have I, and then at the bottom we still have 4. So the twins in this scenario are my 4's. So again, in every twin scenario, 1 cancels, 1 exits the house. So I had a 4 come outside the house, a 3 stayed in, and we still have I. But it's still over 4. And look, the 4 that came outside can reduce now with the 4 that was on the bottom. They will cancel each other out. Oops, I didn't mean to do that. So the last step to simplifying this radical is the final answer, the square root of 3i. So there was a lot built into that problem, but you can handle it. It just takes time and patience. Our last question, number 7. I have a fraction underneath a root. Those are not allowed. So the first step is to separate the root. So that would be a square root of 20 over a square root of 49. All right. Well, 49 is a perfect square. So that's the square root of 20 over 7. If 49 wasn't a perfect square, you would do like we did on number 6. Take that root at the bottom, multiply it on the top and the bottom first. All right, so now I need to just simplify my top, the square root of 20. So put 20 on the side, look for your factors. I don't know any perfect squares that are, oh, 4 is a perfect square, factor of 20. Why is it a perfect square? Because it's 2 times 2. So there we go. So 2 times 2 times 5 is under the root over 7. So if you notice, both numbers under the radical were positive. So I is not involved in this scenario. I is only involved if you have a negative number under your root. Okay, so let's continue to simplify it even though it's not a negative. I have twin 2's, so that means 1 cancels out, 1 escapes outside. So I have a 2 outside, square root of 5 inside, and an over 7 as my final answer. Some other little tips. When it comes to fractions, only numbers outside of the radical can be reduced by the number in the denominator. If the number is underneath the radical house, you can't cancel things out. That's not allowed. So I repeat, it has to leave the radical and be a real number. Or it needs to just leave the radical and be a whole number before you can simplify it or reduce it with the denominator numbers. Okay, this concludes the lesson for today.